Good morning, children. Now, again, we are here to discuss something about electrostatics of conductors. Now, what we have already done is we have already talked about three phenomena, that is electric field. Then we talked about electric force and electric potential, and also electrostatic potential energy between multiple charges. Now, next topic is capacitor. Now, before talking about capacitor, we must know about some properties of conductors also, and then dielectrics, that is the insulator. Now, as we already know that conductors have free electrons to move around in its lattice, but they cannot leave the lattice. So, how is the conduction taking place in a conductor? Suppose this is a conductor. It is made up of atoms, and in metals, what is the property? That the outermost electrons become free to move inside. Like they form a type of gas inside the lattice or inside that material, and they can move around in that region. But the net charge on the surface and in the metal is 0, because all atoms have got equal protons and electrons. Electrons are not leaving the atom permanently or leaving the material as such as permanently going out. So the net charge will be 0, but electrons will be free to move, which are of the outermost orbit. So they are free to move inside. Now what happens to the other part? That is the nucleus and the remaining electrons. What they are going to make? They are going to make positive ions. Apart from that, these positive ions will not move from their positions. It is only the electrons which are of the outermost orbit will move here and there. And how they will move here and there? They will move in arbitrary direction like this, and the net electric field is 0. But if some external field is being applied, then what will happen? These electrons will start moving against the electric field, because electric field will be positive to negative. So electrons will be moving from negative to positive. So they'll start moving like this. Now in case of liquids or electrolytes, it is the positive and negative ions of the electrolyte which will move and will be responsible for conduction of current. Now we are not going to talk about electrolytes as main. This is just, you must know that here ions are responsible for the current, but here it is only the electrons. And in absence of electric field, external electric field, the net directions of these electrons and the movement, they'll behave as if there is no electric field, because they will cancel out each other. They'll be moving randomly. Now we must know these points about conductors. One is, inside a conductor, electrostatic field is 0. This is just, I explained it to you, that in absence of external electric field, these electrons will move in a random manner in such a way that there will be no net movement as such or net effect, and the electrostatic field will be 0. The second point is, at the surface of a charged conductor, electrostatic field must be normal to the surface at every point. So we just suppose if it is not so, if it is not perpendicular, then in that case what will happen? If it is not normal, then what will happen? That if it is not normal, that means it must be making some angle. That if it is making some angle, then there must be a horizontal component. And as we have already said that there won't be movement of electron in a definite pattern in absence of external electric field. Therefore, we must not have a horizontal component. And therefore, at the surface of a charged conductor, electrostatic field must be normal to the surface at every point. The interior of the conductor can have no excess charge in the static situation. So when there is no external electric field, it's just a conductor like this, then they will not have any excess charge. Means either it should have a negative charge or a positive charge. But as the number of electrons will remain equal to number of protons, so there will not be any excess charge. Electrostatic potential is constant throughout the volume of the conductor and has the same value inside as well as on the surface. Now you can see, inside a conductor, electrostatic field is 0, and at the surface of charged conductor, electrostatic field must be normal to the surface. From these 2 points, we can come to this 4th point. See, that means it is going to form an equipotential surface, and therefore potential will remain same. Electric field on the surface of a charged conductor will be E is equals to sigma upon epsilon naught, and certainly electrostatic field, as we already done, will be perpendicular to the surface. Then is electrostatic shielding. Electrostatic shielding. Shielding means we got to prevent it from some. So, electrostatic inside a cavity. We have done in Gauss's theorem also. Inside a cavity, electric field is 0 because there is no net charge as such. So, anything which is kept inside will be shielded from electric field. So, prevent anything from the effect of electric field. We can have a metallic cavity inside which you can keep the things which can be properly shielded, and there will be no effect of electric field. Now we are going to talk about capacitor. Now what we have talked about is the effects produced by charge. Now the question arises, how to store a charge to produce or to study various effects or use it when required. For that, we have got a device known as a capacitor. Now, capacitor is an arrangement of two metal surfaces with charge plus Q and minus Q on each other. That you can say the net charge will be 0, having a potential difference V between the plates and electric field E being created inside the plates. We can have sigma as the surface charge density. This plate is, say, positively charged. And this is negatively charged. It is studied and it is seen that the ratio Q by V always remains constant, and this constant is known as capacitance. We'll again go back here. So capacitor is a device to store charge. Now how this works actually? It is like, now we'll again go to the initial point. Suppose we have a plain sheet or a conducting material. Now what happens is, start giving charge to it. We can give by conduction, we can give by induction. Methods of charging are by friction. Now what will happen when you start giving the charge will start depositing on the or spread itself on the surface of the conductor. And as you will keep on giving the charge, it will keep on spreading over the surface. Now this will be up to a certain limit. After that, what will happen? You will keep on giving a thing, or like you say, if you keep on filling water in a bucket, after some time it will start spilling out from bucket. Rather, you can say it will start leaking out. In the same manner, after a certain capacity, what will happen? The charge will start leaking into the atmosphere. That will not be holded by the same plate. Other reason is also, like all our positive charges, they will also start repelling the other charges if they are extra ones. For that, now to increase its capacity to store charge, what we can do is, we can place another conducting plate near it. Now charges will be induced. Now how the charges will be induced? A negative charge will get induced on this surface. So negative free charges will come here, electrons, and the ions will start on the or spread on the outer side of the surface. Now what is the change now? The change is, because of this negative charge, some more charges can be given to this configuration, because this negative charge will now make these positive charge attract toward themselves and will allow some more positive charge to get spread over this surface. To further increase the capacity to store the charge, what can be done is, now you earth this plate. These positive charges will get earthed. These negative charges, because of the attraction from this positive charge, will remain here itself, and this positive charge will now go to the earth. So can be removed. And now everywhere this negative charge will be there. Positive charge has now gone to the earth. Now what will happen now? Further, a little bit more capacity will be increased to store the charge. As beforehand, what was there? There was an attraction because of these electrons, but there was a repelling force also because of these positive charges. Now there are only electrons, so a little bit more capacity for storing the charge will be there, and therefore now a little bit more charge can be given, and in this way a capacitor works. So a configuration in which we have got two plates, or we can also have two spheres, or we can have two cylindrical coaxial ones. They will form a capacitor. They will form a capacitor. This is known as a parallel plate capacitor. This is known as a cylindrical capacitor. This is known as a spherical capacitor. Now in our course, we'll only be talking about parallel plate capacitor. We'll now come back here again. So this type of configuration will give rise to a capacitor. Will have charge densities like this. A potential difference will be created like this. Net charge will be 0. Electric field will be created from positive to negative charge. Sigma is the surface charge density. And what is being seen? That potential difference created is directly proportional to Q. You can say it like this. Or we can say that V is equal to, from here, Q is proportional to V and Q is equals to CV. Q proportional to V. When you remove the positive sign, you will get a constant. Here it will be C, and C is known as capacitance. Now since this is a constant, that means the ratio Q by V will be constant. What is the unit of capacitance and how do we define? Now definition can be done from expression itself. Capacitance, now from here C will be equal to Q upon V. So capacitance of a capacitor is said to be 1 farad. Unit of capacitance is 1, like farad only. When we'll define unit, then we'll write farad, which is denoted by F. Usually a smaller unit is being used, that is microfarad. That will be 10 to the power minus 6 farad. We'll also use nanofarad, that is 10 to the power minus 9 farad. Picofarad, that will be 10 to the power minus 12 farad. So a capacitor is device to store electric charge. Capacitance is the ratio of Q and V, which is a constant, and we can also define as capacitance of the capacitor is the ratio of the charge given to the capacitor to the potential difference being created between the plates. Unit of capacitor is farad. And how will we define 1 farad? Capacitance of a capacitor is said to be 1 farad when a charge of capacitance of the capacitor is said to be 1 farad when a charge of 1 coulomb is being given to the plates of the capacitor, which gives a charge or creates a potential difference of 1 volt. These are the different units: farad, a smaller unit microfarad, and picofarad. Now the value of capacitance depends upon the shape, distance between the plates, shape of plates, and configuration. That is how much is the length, how much is the breadth of the plates. We have already talked about the spherical and the cylindrical one, but that are not to be studied. You must only know that there are other 2 types of capacitors also which can be used. We will be dealing only with parallel plate capacitor. This type of capacitor is known as a parallel plate capacitor. Now capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. We know C is equals to Q upon V. V can be written as ED. E can be written as sigma upon epsilon naught into D. Sigma can be written as Q upon A. Q upon A into D. See, now these are in basic values. So V can be written as Q upon A epsilon naught D. So what is the value of C now? Q upon, now I'll substitute the value of V from equation 2 in 1, Q upon Q A epsilon naught into D. Q and Q will cancel out. C is equals to Q upon QD A epsilon naught. This is going to give me epsilon naught A upon D. I'll again repeat what we are going to do. We are going to find out capacitance of a parallel plate capacitor. हमारे पास ऑलरेडी क्या फॉर्मूला है? C is equals to Q upon V. Q पहले से ही बेसिक क्वांटिटी है. V को लेकिन हम जो हम चीजें जानते हैं उनके हिसाब से लिख सकते हैं. तो V is can be written as E into D. Now from where we have got this formula? You know that what is E equals to 1 by 4 pi epsilon naught Q upon R square. And what is V? 1 upon 4 pi epsilon naught Q upon R. So if I multiply V by R, what will happen? I'll get only Q, but if I multiply E by R, multiply E by R on both the sides, what you will get? This is going to give me 1 by 4 pi epsilon naught Q upon R. So what it is? It is V. So V is equals to E into distance. So V is equal to E into distance. This distance is between the plates of the capacitor. So D will remain as it is. E can be written as sigma upon epsilon naught. We have done in electric field due to a sheet of charge. So that is sigma upon epsilon naught directly being used. In place of sigma, you can write down Q upon A. Substitute it here. I'll get C is equals to epsilon naught A upon D. So this is the capacitance of a parallel plate capacitor with air as the dielectric medium between the plates of the capacitor. If suppose there is different medium than air, then in that case it will be changed to EM, and that will give you K epsilon naught A upon D. So in case of medium of dielectric constant K between the plates, C will be K epsilon naught A upon D. So this much you remember. Try to derive this expression, and tomorrow we'll be doing, if I'll keep a dielectric medium here in this case, and that too not between the, not filling the space, then what will be the value of capacitance? Thank you.